Okay, so our last type of factoring is with DOPS, and this stands for the difference of perfect squares. So difference meaning subtraction. You can subtract perfect squares meaning numbers like 4, 9, 16, 25, 36, because you can take the square root of every single one of these and get a whole number. Like square root of 16 gives you 4, square root of 25 gives you 5, square root of 36 gives you 6, so on and so forth. Okay, so the difference, the subtraction of perfect squares. This only works when you are subtracting two terms and you can take the square root of both. So what you do is you set up factors, x in both spots in this first case because we just have to make x squared. And you put a plus in one and a minus in the other. Your parentheses should look identical except for the plus and minus. Let me just write that out. Identical parentheses. Parentheses. But one is plus and the other is minus. Okay, so you set up your parentheses and you take the square root of both terms. So I square root both sides and I get, well, square root of x squared gives me x. Square root of 49 gives me 7, which goes in both spots. And again, it's equal to 0. If I were to distribute this back out, I would find that my terms combine, and I'll just do it quickly. You don't have to write this down, but just understand you can do it. X times x gives me x squared. Negative 7 times x is negative 7x. Positive 7 times x is positive 7x. 7 times negative 7 is negative 49. When I combine these middle terms, they cancel. Negative 7 plus 7, gone. So now I'm left with x squared minus 49. So that checks out, which is cool. But again, you don't have to do that. All I'm saying is that it's helpful to check your work. All right. So back to x plus 7 and x minus 7. Because it's equal to 0, we do have to solve. Okay, so x plus 7 equals 0, x minus 7 equals 0. Solve it, and you get x equals negative 7, x equals positive 7. So curly brackets, negative 7, comma, positive 7. All right, example 2, we've got 16x squared minus 25. It is the difference, the subtraction of perfect squares, because I can square root both terms. Parentheses, parentheses, equals 0. Plus and minus, we're good to go. You like that little song? All right, square root of 16 and square root of x squared gives me 4x for both spots in the front of each parenthesis, because remember they are identical except one is plus, one is minus. Square root of 25 gives me 5 in both spots. Because it's equal to 0, we do have to t-chart. 4x plus 5 equals 0. 4x minus 5 equals 0. Solve each side for x, so we have 4x equals negative 5. Divide by 4 and we get x equals negative 5/4. On the right hand side I add 5. 4x equals 5. Divide by 4 and I get x equals positive 5/4. Curly brackets, negative 5/4, comma, 5/4. And last but not least, something called factoring completely. These questions require you to factor more than once. Okay, so usually that means GCF first or DOPS first, and then you get to try add multiply. Okay, so remember your 3 factoring methods. Sometimes it could be a tricky trinomial. where you do have to guess and check, but it just depends on the problem. So I'm going to look for a GCF first, because I have 3 terms, and that's not the difference of perfect squares. I'm trying to think to myself, could I divide each of these coefficients, each of these numbers, by 3? Yes, I could. And then I look at their variables, the x to the third, x squared, and x, because x is in each of them. I take the one with the lowest power. So now my GCF is 3x. So I divide every term by 3x, and I have a big, huge pair of parentheses left over afterwards. So when I divide, I get, 3's cancel. X to the third divided by x leaves me with x squared. Okay, so I had 3 of them up top. I divided by 1 of them on the bottom. 1 pair cancels, and I'm left with x squared. Okay, now I have 21 divided by 3, which leaves me with 7. X squared divided by x, so that's 2 on top. Divided by 1 on the bottom. 1 pair cancels, left with 1 on top. Plus 36 divided by 3 leaves me with 12. X divided by x, well, they cancel. But guess what? This is the coolest thing in the world. At least for somebody that loves math like me. I get to factor again by add multiply. Because now this middle piece here can be factored further. It's not DOPS because it's not the difference of perfect squares, and it's not a tricky try because there's no number in front, but it is certainly add multiply. So now I have to keep the 3x in front. I'm just bringing my work over here because I know my space is tight. And this time I'm setting up 2 pairs of parentheses afterwards equal to 0. Because I know that when I factor with add multiply, I get 2 pairs of parentheses out of it. So now I have x in the first spot of both, and I have to add to 7 multiplied 12. So off to the side I'm thinking 12. Breaks down into 1 and 12, 2 and 6, 3 and 4. I pick the pair that will help me add to 7. 1 and 12 will not do that. Neither will 2 and 6, that would give me 8. 3 and 4 helps me add to 7. Because I'm multiplying to a positive and adding to a positive, my signs must match and both be positive. Oh boy, T-chart is fun here. Because now I get 3 T-charts. I have 3 terms, 3x equals 0, x plus 3 equals 0, and x plus 4 equals 0. First one I just divide by 3, that's the easy one. I get x equals 0. Second one I subtract 3 and get x equals negative 3. Third one I subtract 4 and I get x equals negative 4. So final answer solution would be negative 4, comma negative 3, comma 0. Or again, you could box in your x equals. Alright, the last example in this video, we've got x to the 4th minus 81 equals 0. Because this is an even power, I could take the square root of it. And because this is 81, I can take the square root of it. There's no GCF, there's nothing in common, there's no x's in both of them, so I can't take out a GCF. So I'm going to try DOPS. If I take the square root of x to the 4th, I get x squared for both. I know that they have to be identical parentheses, just like we talked about earlier in the video, except that one has a plus and one has a minus. And then square root of 81 gives me 9. This first one, x squared plus 9, nothing more can happen to it. It's a positive, we're summing them. There's no GCF, so I'm just going to copy it. But this second one, x squared minus 9, can actually be factored again. Because it's the difference of perfect squares. Difference meaning subtraction, perfect squares meaning I can take the square root of both. So x in the first spot of both, because square root of x squared is just x, plus and a minus. Square root of 9 is 3. And then because it's set equal to 0, we do have to solve. So find yourself some space and make your triple t-chart. Alright, so we have x squared plus 9 equals 0. Subtract 9. And now we have x squared equals negative 9. So from here, to find just x, we have to take the square root of both sides. Something that you should have learned back in Algebra 1 but may have forgotten is that you can actually take the positive and negative square root of values. Because remember, if I take the square root of 9 in the positive value, we get positive 3. But if I take the square root of 9 in the negative value, I could get negative 3. And the reason for this is that negative 3 times negative 3 is actually positive 9. Or positive 3 times positive 3 is positive 9, which is why we have the plus and minus square root of a number. You don't need to write that stuff down that I just wrote, but just keep that in mind. We're not going to simplify this because it's a negative under the square root, and so far right now you know nothing about negatives under a square root. We'll get to that eventually this year, but don't stress about it, just leave it as is. X equals plus or minus square root negative 9. Then we have x plus 3 equals 0, x minus 3 equals 0, and solve those. Life is easy. X equals negative 3, x equals positive 3. And then if you want to write your solution set, you have negative 3, positive 3, and plus or minus square root of negative 9. And there you have it, factoring completely and factoring using DOPS, difference of perfect squares.